The final outcome of the experiment is here. There, if we break down by pepsin, we get a large molecular weight segment which can bind with antigen. Okay, and therefore we call it antigen binding site, or FAB, fragment antigen binding. Okay. Now, if we do with this thing, what do we call is beta markup to ethanol, we find 4 different proteins, and all 4 different proteins can bind with an antigen, but only on a single side, not in both sides, because these are the 1, 2, 3 and 4. So all the 4 chains will bind it. So what does it mean? It means that there are 4 different entities which are combined. Here what is happening? You are getting a single chain of large molecular weight, because these disulfide bonds are not yet broken. So it is the same chain only, isn't it? And therefore we got a what? Single band. So the whole band can bind with antigen, and after adding beta markup to ethanol, we come to know, okay, this whole band is in fact part of 4 different what we call chains. Okay, so that we come to know. Finally, when we break down the whole thing with pepsin, we come to know some more information. What is the information? That there could be 3 different what do you call is parts. Out of the 3 different parts, only 2 parts can bind with antigen, that is this part and this part, but there is one more tail which cannot bind with any antigen, so we call it FC. So after confirming, like, this is how previously the structure of a protein can be deduced when there was no what? X-ray crystallography. Now what you can do is you can directly see the structure of a protein. For example, like this. For example, like this it is. I'll show you a protein like this. L1 domain. Interaction. Just if it is there, I'll show you. Let us see here. Okay. For example, okay, for example, this is a what do you call X-ray crystallograph of a protein. Okay, how exactly it look, we can deduce everything. Okay, but once upon a time it was not there, it was not possible. In that time, what we do, we used to do this kind of this thing on experiment only. By doing these experiments only, we would have understand what are the different domains. Okay, now what is this thing is, you write down the question. Plus monitor, you write down the question. Number 1, write 5 characters of globulin. Write 5 characters of globulin. Number 1. Number 2, explain why globulin is having a higher molecular weight than albumin. Okay, explain why globulin is having higher molecular weight than albumin. So in this question you write about everything, that globulin is so big that it cannot come out of the body very easily in comparison to albumin, which can come out of the body through urine in cases like proteinuria, and proteinuria takes place in various conditions. For diabetic nephropathy, then there are other kidney disease, and then infection, and then some physiological condition also. For example, pregnancy. In this case also protein will come out through urine, physiological conditions. So okay, so where proteinuria will take place? when you will find proteinuria, these are the cases where proteinuria can be seen. Okay, so next third question you write that explain an experiment. Third question, explain an experiment to show globulin is less soluble in water. Globulin is less soluble in water. Okay, so for that what you will write? You will write this experiment only, that you have taken a sample where globulin is there, and then how you will do globulin. Okay, so if you precipitate the albumin, for example, when we do albumin globulin ratio, then what we do, you know, we at first do total protein estimation by biuret test. Okay, so total protein will give us what is the condition. Then what we do, we precipitate the albumin by adding a particular reagent. We precipitate the albumin, then only globulin is remaining. Then again we quantify globulin. So from total protein, if we remove globulin, what will happen? Albumin will be there, isn't it? So I'll show that thing also. For example, at first we will find how much total protein is there in the blood. Total protein kit we will use. Okay, subsequently we will use albumin kit. Okay, and then what we will do, total protein mg per deciliter, okay, minus albumin. So what it will give us? It will give us globulin. So from this, what we will do, we will determine albumin globulin ratio. Very, very important. Okay, understood? So finally what we will find? We will find AG ratio, albumin globulin ratio. Okay, so next question you write, write something about plasma therapy. Okay, I will not ask for passive immunization. You do not write passive immunization also. You just give an example of COVID-19 and then say that what exactly happens. Okay, in plasma therapy, if somebody is recovered, we take their plasma, then purify it by HPLC. Okay, one figure I showed you. So you will write like this: accumulate plasma from recovered patient by apheresis. Apheresis is the method by which you can separate plasma from all other blood components. Then what you do, we purify, we check the purity by various kinds of chromatography. One such chromatography very helpful and very sensitive, HPLC. After that we will put that plasma back to the patient. But you should be very, very careful that in your plasma there are no other viruses, because many a times through blood transfusion and through plasma transfusion, several other viruses can enter into your body, because you are taking body fluid of somebody else. Okay, it is something like using a dirty needle, so you may get infected with HIV. So you are safe from corona, you are infected with HIV. These things can happen. So this thing is very important, and you must input also this thing. What is plasma therapy, not passive immunization. Okay, then you write about what are the you write one question. Do not try to use internet, you try to listen from this class only, because if you go to the internet you will get plenty of other unnecessary information. So one mark question you also write, what do you mean by X-ray crystallography? In 2 lines only you write that X-ray crystallography is a method by which we can identify structure of a protein with with much detail. Okay, so next question you write, when we digest antibody with